Graph of inverse proportion. From the previous lesson, we have demonstrated that two quantities involved in an inverse proportion have a relation of type A times B equals constant, which we can write as the following shown on screen. Or we obtain the following shown on screen. The graph of this relation is called hyperbola. It is a curved line that approaches the axes without touching them with the increase in the values of A and B. To increase the accuracy of an inverse proportion graph, we must use as many points as possible. Thus, if we reconsider the previous example, we can form the following table shown on screen. We can write the time axis in the horizontal direction as we do in physics, while the speed values are placed in the vertical direction. We have the following shown on screen. The following example provides a closer look at the graph with the part corresponding to the small values shown. This is provided to make the values of the table more evident. We have the following shown on screen. Example. The graph of an inverse proportion is shown in the following figure shown on screen. A. What kind of proportionality is this? B. Calculate the constant C of this proportionality. C. How many people are needed to dig the same hole in half an hour? D. How long does it take to a single worker to dig the hole? Solution. A. The graph shows an inverse proportion as the graph shape is a hyperbola. B. Since we have an inverse proportionality, the relation involved has the general form shown in the following on screen. Where B represents the number of people needed to dig the hole, A represent the number of hours needed for this work, and C is the constant of proportionality. From the graph, we see that 12 people can dig the hole in 2 hours, B equals 12, A equals 2. Other values that are clearly spotted in the graph include 8 people in 3 hours, B equals 8, A equals 3, 6 people in 4 hours, B equals 6, A equals 4, etc. If we substitute one of the sets of values, for example the first from earlier, in the general form of the proportion, we obtain the following shown on screen. Hence, the constant of proportionality C is the following shown on screen. Therefore, the inverse proportionality shown in the graph is as shown on screen. C. Knowing the formula of this inverse proportionality helps us find other values not indicated in the graph. Thus the number of people are needed to dig the hole in half an hour, A equals 0.5. We have the following shown on screen. D. If there is a single worker available, we have the following shown on screen. Therefore it takes 24 hours to dig the hole. That is all for lesson 4.3.6 and the end of tutorial 4.3. To continue this chapter, please watch 4.4 Properties of Proportion. Geometric mean. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.